Hey guys, welcome back. Our trivia question and answer from 6.1 was extensive properties. It matters how much you have, not what you have. So let's jump right into 6.2, the nature of energy, key definitions. So let's start by defining a couple of words. First off, energy. Energy is our capacity to do work. Capacity to do work. Then, since we have work right here, we probably need to define work. And work is force acting through a distance. So basically, there has to be movement here. Force acting through a distance. And our last one is heat. And heat is probably one that we're going to have to change our definition just a little bit on. And this is transferring energy from high to low. From high to low. And this is usually due to a temperature change or a difference in temperature. So let's jump into the two major types of energy. Our two major types of energy are kinetic energy and potential energy. Kinetic energy can be defined as energy in motion. Potential energy is energy that is stored or energy due to its position. For instance, holding my laptop up above the ground, it has more potential energy than it does sitting on the ground. Thermal energy actually fits under this kinetic energy umbrella because we're talking about the energy related to temperature. And if we remember our definition of temperature, temperature is the average kinetic energy of the particles. So basically, how fast are those particles moving? So the average kinetic energy of the particles. And the last one here, and probably the one that we're going to be most concerned with in this class, is chemical energy. And chemical energy is the energy due to the nucleus and the electrons, the attraction of those guys there. And what would we call that? We would call that, or where have we talked about that before? This is Coulomb's law. All right. One thing I wanted you to remember that they touch briefly on in this section is that breaking chemical bonds always takes energy. When we break bonds, we add energy. So let's jump to the law of conservation of energy. And the law of conservation of energy says that energy can never be created or destroyed, cannot be created or destroyed, only transferred. What's interesting about this is the fact that we cannot create any more energy according to the law of conservation of energy. So what we have is what we have. Moving on to a couple of different things, a couple of different words under law of conservation of energy. We have system, and system is where the chemical, let's say where the particles that are reacting. So our system is our particles that are reacting. So this is actually quite small most of the time. And what I've heard defined as surroundings is everything else in the universe. Because they're surrounding that chemical reaction or the system, everything else in the universe. And last but not least is our units of energy. We have the joule, which is the SI unit of energy. So we use that anytime we have energy. The one thing is the joule is really small. So oftentimes we use a kilojoule, which is, if you recall, equal to 1,000 joules, because the joule is so small, because it's equal to the amount of energy that it takes to move a 1 kilogram object 1 meter at an acceleration of 1 meter per second squared. The other type of energy, or the unit of energy, that you've probably heard of before is the calorie. The calorie is defined as 4.184 joules. This used to be defined as the amount of energy it took to increase the temperature of 1 gram of water by 1 degree Celsius, but that has since evolved just a little bit. And the last one is our American unit of the kilowatt hour. And so if you're paying an electrical bill, it will tell you how many kilowatt hours you've used in the month. And that's it for 6.2. Thanks for joining me. Seeing you next time.